Hello friends, and welcome at my channel. In the last video we discussed the basic idea of an inverse function, and I told you at the end of the video that we're symmetric considering the identity function, but there is a very important question: why is it this way? And let us answer this question today. Alright, so if you remember, if we're dealing with f of x and f of y, or f of x and the inverse f to the power of -1 of x, what do they do? I mean, if I know that f of x1 gives me y1, then the inverse function is sending me back. So it brings y1 to x1, correct? This is the idea of the inverse function. And so, once again, let us do an example. If f of x is 2x plus 3, let me keep it simple with linear functions. Later on we'll have more and more difficult functions, and I will show you also how to figure out the derivatives and all that kind of stuff. We'll be doing it, no worries. But let's keep it simple now. So if I put, for example, 3 for x, I'm gonna get 2 times 3 plus 3, so it's 6 plus 3, it's 9, right? So the inverse function, I do not even know what it is right now, but I know, so question mark, but I know that the inverse function at 9 must give me 3. That's it. This is what I know for sure. Can I compute it? Can I check it quickly? Of course we can. So if you remember, I told you y equals to 2x plus 3. Solve it for x. So that means 2x equals to y minus 3 division by 2 gives you x equals to a half y minus 3 halves. So the inverse function, I'm claiming, and you believe, trust me, it's a half of x minus 3 halves. So if you put for x9, we're gonna get 9 halves minus 3 halves, which is 6 halves, and this is 3. So that perfectly works. But let us look at those points. So the first point, let's call it A, would have coordinates x1 and y1, and the second point, let's call it A star, would have the coordinates y1 and x1. So I do not know what they look like now. I was telling you 3 and 9, right? So 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So somewhere there is the first, and at 9, 3, 4, 5, 6, 7, 8, 9 would be the second one. So this is all I know. Okay, let me write it here. 3, 9 in our examples, and 9, 3 right here. Can I figure out the slope of this function? Of a obviously linear function connecting those 2 points? Yeah, I can. So these are the y values, and these are the x values. So m, the slope, would be x1 minus y1 divided over y1 minus x1. I can take minus outside of the parentheses here. I'm gonna get y1 minus x1 divided over y1 minus x1, which gives me minus 1. Well, that's nice. We have minus 1 as a slope. But the thing is, it works for every point on the graph of f of x, because every time what's happening is we're interchanging the positions of x and y values. So that means every point we have would be reflected somehow, or shifted. Sorry, I'm saying already reflected. It's somehow shifted to another point where the coordinates are just changed. Okay, and we have always the slope of -1. But what is the slope of the identity function? What is the slope of f of x equals to x? Well, this is 1 times x, right? So the slope is 1. And I hope that you remember. If don't, I'm gonna link a video here on my channel where I proved that if two lines are perpendicular to each other, the product of their slopes must be -1. So if m is -1 in our case, obviously the product of -1 times 1 gives you -1. So that means every point A can be connected with the point A star, and every time we're doing it, we're always having a slope of -1. And this is always perpendicular to the identity function. And that's why the identity function is a kind of mirror. And we are mirroring the reflecting, the original function, and the inverse function, considering y of x equals to x. Okay, I think, or I hope you see it as well, this is the simplest explanation that I personally have. There are a few more, like more sophisticated. You must understand what's happening and what the symmetry, axis, and so on. But I think this is truly the easiest one to get. All right, in the next video, we're gonna prove how to figure out the derivative of the inverse function without even knowing it. Thanks for watching. See you in the next video. Bye bye.